Okay, so follow up to the previous video. Let's stick with the same function, but this time, let's talk about what does it mean to say, let's evaluate our function called f for something besides a number. Because we can just plug in a number, do our order of operations, and simplify all day long. Okay, but can I evaluate this for something besides a number? And obviously the answer is going to be yes, otherwise I wouldn't ask the question. So what if I want to evaluate it for something else like just h? What does that mean? Well, on some level, we're going to do the same thing with h that we did with the numbers. I'm going to take that h, I'm going to plug it into the function everywhere there was an x, and then I'm going to simplify as much as possible. So what does simplify mean here? It means get rid of parentheses and combine like terms. So when I take that h and I square it, well, that's just going to be h squared. And then plus, what happens, or what do I get? Excuse me. There we go. What do I get when I multiply 12 by h? I get 12h. What do we do with that minus 10? Nothing. I just bring it down. And then I've gotten rid of parentheses. So combine like terms. Do I have any like terms here? I don't. So what is f of h? F of h is just what we're looking at. H squared plus 12h minus 10. That's it. And on some level, it looks like all I did was change the letters from x's to h's. And that seems true. So I just want to introduce this idea that we can evaluate a function for something besides a number. Why would we do that? I'm not really going to satisfyingly answer that question. I'm just going to say we do it for calculus-y reasons. So in that same spirit, for calculus-y reasons, what is f of something else? I'm going to set up my skeleton. I could have paused the video. You didn't have to listen to me click, 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 and narrating all this. I could have done that. Anyway, it's too late. So what do I want to evaluate it for besides h? How about x plus h? So what do I do with that x plus h? Same thing I've done with everything else. I'm going to plug it in to the original function everywhere there was an x. So instead of x squared, I'm going to write that as x plus h squared. Plus 12 times instead of x, I'm going to call that x plus h. So that's the plugging in step, but I still need to simplify. Simplify means get rid of parentheses, combine like terms. So let's get rid of parentheses first. I have parentheses here, and I've got parentheses here. So in order to get rid of this first set of parentheses, I'm going to have to FOIL that mess out. What do I mean by that? Let's off to the side, let's work out what x plus h squared is. Okay, so we just said that x plus h squared is x squared plus 2xh plus h squared. So this is equal to that. But I had this other set of parentheses that I need to get rid of. And this time, how do I get rid of these parentheses? Well, I distribute that 12. So we're going to say plus 12 times x is 12x, and 12 times h is 12h. So now, having distributed that 12x plus 12h is equal to that. But I still have this minus 10. Don't forget it. Bring it down. So that completes the step of simplifying by getting rid of parentheses, but I still need to check, are there any like terms that can be combined? So let's look carefully. I've got 1x squared here. Do I have any other terms that are plain old x squareds? No, 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 and no. So I'm going to bring that x squared down. There was no like terms to combine it with. Then I look at my xh's. I've got two xh's here. Do I have any other terms that have both x and h? Remember, to be like terms, you have to have the same variables raised to the same powers. So this doesn't have an x. This doesn't have an h. This doesn't have an x. This doesn't have anything. So the plus 2xh has no like terms. Same thing for h squared. Look down the road. Are there any other h squareds? Nope. 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 So we have plus h squared. I've got 12x's here. Are any of the rest of the terms plain old x's? Nope. Nope. Plus 12x. And by now you're probably expecting it. Plus 12h. No like terms to combine there. And then minus 10. No constant terms. So what do I get when I evaluate this function for x plus h? Once it's simplified, it equals this alphabet soup right here. X squared plus 2xh plus h squared plus 12x plus 12h minus 10. Why did we do that? I'm not going to tell you. I told you it's going to be an unsatisfying answer. It's just a skill we need that's going to be helpful in a few semesters. All right? So while I've got you here is a handy reminder that if you look at this and think, okay, I'm just going to square the x and the h and call it x squared plus h squared, you're dead wrong. And I'm not going to be able to grade that work. So instead, what does it mean to square something? Excuse me. What does it mean to square something? It means you are multiplying it by itself. Let's see if I can fix this too. Boom. So that is going to be x plus h times x plus h. So now I can do first is x squared. Outer x times h is plus an xh. And then when I do h times x, I'm going to get the same thing. And I could write it as hx, but I'm going to keep it in the same order that I had over here. I'm going to call that xh. And then finally, h times h is plus an h squared. I combine any like terms I have. Those two terms in the middle are like terms. So if I have one xh plus another xh, then I've got 1x squared plus 2xh's plus that h squared. So I'm going to take this thing, and I'm going to go back to where I was simplifying, and I'm going to plug that in.